Hi Math, I'm Andy. Today let's take a look at scientific notation and how to divide when using it. So let's say I had a number in scientific notation 6 times 10 to the 8th, and I want to divide it by 3 times 10 to the 2nd power. Well, because this is division with multiplication, one way to think about this is we can kind of do things in any order. We can simplify things when necessary and still leave it as multiplication. So how I'm going to do this is break it up. I'm going to take the numbers 6 divided by 3 times the exponents 10 to the 8th divided by 10 squared. So it's almost like I'm going to take each of those pieces and work with them separately, because I know that 6 divided by 3 is equal to 2, and I know that 10 to the 8th divided by 10 squared follows our quotient rule, where I actually can subtract those exponents together, and I end up with 10 to the 6th. And so I've taken two scientific notation numbers and I've divided them, and I've produced another scientific notation number. And the way I can do that is to check that this is in scientific notation, because I need this number to be greater than or equal to 1 and less than 10. And because 2 is bigger than 1 and less than 10, it looks like I'm okay, and I've written this in scientific notation. Now let's check out just another example, just so you can kind of see how this works. Let's take the number 1.2 times 10 to the 3rd, and let's divide it by, say, 3.8 times 10 to the 5th, just to make things a little tricky. 3.8 times 10 to the 5th. Now we're going to use that same technique. We're going to break the numbers up and break the powers of 10 up and do that division. We get 1.2 divided by 3.8, and just to kind of skip this division, this is equal to 0.3157, and the number keeps going. It's this irrational number, but I'm just going to cut it off at 4 decimal places. Then my power of 10 is 10 to the 3rd divided by 10 to the 5th, and using that same rule that we used above, we can subtract these exponents, and I end up with 10 to the negative 2 power. 3 minus 5 is negative 2. So if I were to write this answer in a what would be a scientific notation fashion, I'd get 0.3157 times 10 to the negative 2. And I ask myself, is this in scientific notation? But because it doesn't fit that standard, this number is not bigger than 1. 0.3 is less than 1. I need to adjust my answer. I need to take this decimal and swing it over 1 place to the right. So I'm going to change 0.3157 into 3.157. And I'm going to multiply this times 10, and then when I think about the way that my answer is written, a negative 2 tells me to move the decimal 2 places to the left when writing it in regular terms. But because I moved the decimal 1 place to the right to adjust my answer, I'm going to need to account for that extra power of 10 movement. And because I'm moving the decimal left to do a final answer, and I had to move it to the right to account for it, I need to actually take a power of 10 away. And so we have 3.157 times 10 to the negative 3 power instead of negative 2, because again, I had to account for that decimal's movement. So this has been scientific notation dividing. We divided the numbers, we divided the powers of 10, and then we accounted for any non-scientific notation answer by changing our powers of 10.